we'll see expression will derive that. Suppose f of z is given as u of x comma y plus I times v of x comma y. Okay, suppose this is a function given and you are given that derivative exists. Suppose f dash of z exists. So can you give some condition on u and v which is satisfied by u and v or something, some partial derivative, something like that. So we'll see, we'll try to find out some relation between ux and vx. Ux, that means I'm talking about partial derivative of u with respect to x, something. I just want to relate this ux, uy, vx, vy. Correct? I just want to relate. Suppose I'm giving the function, this is function and derivative exists. Then does this satisfy some relation? Does there is some relation between them? Let us see. Correct? So as I already told you, how do you define derivatives? Suppose if I'm say derivative exists at a point z naught. So you already know what is the definition of f dash of z. Z naught, let us see. F dash of z naught. It is limit delta z tending to 0. Correct? What is that? Yes, z naught plus delta z minus f of z naught divided by delta z. Correct? And what is your function defined? F of z is equal to u of xy, v of xy. When you put z naught plus delta x, then let us see what are the changes it is going to happen. First, let us define. Suppose z naught is equal to say x naught plus iy naught, and delta z will be same as delta x plus I delta y. Correct? So this will be changed as क्या आएगा ये बोलो? If you put it here, then let us just solve first little bit. Mm, then f dash of z, that is equal to limit delta z tending to 0. What will be this? F of z naught plus delta z. Do you see the first coordinate? What will be u? Z naught plus delta z. So it will be x naught plus delta x. We agree? Minus f of z naught. It will be, oh sorry, it should be u plus iv, na? Plus I v. V will also be the same, having same coordinate. That is x naught plus delta x, comma y naught plus delta y. ये हो गया. Minus, what is minus? That is f of z naught. That will be u of x naught y naught minus v of x naught, sorry, plus a v of x I into x naught y naught. So is that clear? Is the expression clear to you? कैसे लिखा हम लोग ने? And here I am taking that is delta z, so it will be delta x plus I delta y. F of z naught plus delta z, I am writing it as the coordinate will be z naught plus delta z. Z naught is x naught plus I y naught. Delta z is delta x plus I delta y. So this is what I am having. Correct? Is that clear to you? Now you can do one thing. You can take both the real part together and imaginary part together. So observe something. If you take real part together, that means you're having this part and this part. Correct? That will be your real part. And what is your imaginary part? Plus I into this one. Just try to see. Have you seen something like that? What is your real and what is your imaginary part there? Have you seen something? Hello. Yeah. So if you observe something here, this is u of x naught plus delta x, y naught plus delta y minus u of x naught y naught. If one of the term, either delta x or delta y is 0, suppose delta y is not there, that is u of x naught plus delta x comma y naught minus u of x naught y naught, and here also you are not having delta y, the upon delta x, so it will become the partial derivative of ux. Do you remember the definition of ux? Or if I talk about fx, what is definition of fx? Is there anyone who can tell me the definition of fx? Partial derivative, do you remember the definition? Yes. F of e plus h comma b minus f of eb upon h. Do you remember this? Upon, it should be upon h, like that, correct? And if you put a comma b plus h minus f of ab upon h, or mostly people used to say k, e comma b plus k upon that here k, then it will be fy, correct? Partial derivative with respect to x. Yeah, I'll just erase this thing, just is to remind you if you remember the definition or not. Yeah, so let us take real part together and imaginary part together and see what is happening. And before one thing, uh, before that, now you see that your this one delta z, delta z tending to 0, that means what? That means what? Delta x comma delta y, that is also tending to 0, tending to 0. And you know one thing, that is you are given derivative exist, that means this limit exists. If you are aware this limit exists and delta z tending to 0, then if you take any path, that is you are coming from any path, then also this will be 0. The same thing I am going to use, that is I will be coming from real axis and I will coming from imaginary axis, something like this. So here it is delta x, here it is delta y. Now if this limit exists, correct, then what can I say? Since I'll write here, since the above limit, above means that previous slide exist, so delta x comma delta y tend to 0 0 in any manner, that is if you come from any direction, either of this direction or this direction or any direction, you will be getting the limit any manner that we choose, that we may choose. Okay, so in particular what we are going to consider, let's come from real axis. That means what I am going to choose, I am going to choose delta x comma 0, correct, and that tends to 0 0. That means what I have to substitute in the previous expression, I have to substitute at the place of delta y, I have to substitute 0, correct? So let us write now. So f dash of z is equal to, now This will become, now let us write together. This will be as it is. At the place of delta y it will be 0. See, I asked you already, that is, observe, if this is 0 then we will be having some partial derivative, something like that, something ux dx, something will be there, correct? And how did I do that? Since my this limit exists, as I am telling that the function is differentiable and derivative exists, this was my assumption in the starting. Now if this limit exists, so delta z tending to 0, this if I go from any path, this is true, so I am taking from real paths. Similarly, in the next case I will be going from imaginary path. In that case delta x will be 0, and in that case I will be getting some uy. Let us see what you will be having. U of x naught plus delta x comma y naught, y naught, that's it, minus u of x naught y naught upon delta x. I hope that is clear to you. Once you do by yourself, you will see. Limit, you will be having delta x tending to 0 only, and here it will be u of x naught plus delta x comma y naught minus u of x naught y naught divided by delta x, correct? Plus I times, what are you having here? It is I. If you're taking here also, it will be v of x naught plus delta x comma y naught. If you multiply I here minus here, then it will be again, yeah, just you have to take I common. If you take I common, you will be having, should I put the limit here also? Limit delta x tending to 0, yeah, it will be v, na? It will be v of x naught plus delta x comma y naught minus v of x naught y naught upon delta x. Okay, now can somebody tell me what is this value, this limit? Yes, anyone? What is this value? Or you can say derivative, that is left hand side exists, this limit exists. So if the left hand side exists, then this both limits should exist, and you already know this limit. This is your ux at x naught y naught, if you write it properly, correct? And this will be plus I vx. Do you see that? That means now you are having, you will, if you are having a function that is given as u plus iv, you can directly write the derivatives, correct? In earlier cases I told you, when my function is completely in terms of z, then I'll treat as a real number system, and I'll do the derivative as we were doing there, correct? Now the question was, if my function is not in that form, if my function is in this form u plus iv, then can I have something related to that, so that derivative will be easy to do? So now we are having, do you see that derivative will be just partial differentiate u with respect to x plus just partial differentiate v with respect to x. So answer will be f dash of z is equal to ux plus ivx, correct? Do you agree, everyone? Till that, is there any doubt? I started with derivative exist, I wrote the definition, I take real part together, I took the imaginary part together. Then what next? Since my limit exists, so if I go from any direction it will exist, so I am going from real axis. So from real axis I am having delta x. Now one may ask, sir, what about imaginary axis, correct? So let us go from that. I'll just write it as equation 1. Again, since delta z tending to 0, so if you go from any manner, then it will go to 0, correct? So what manner should I go now? Yes, let us take from this direction, that means delta y tending to 0, and take delta, that means horizontally, you can say vertically. We go from vertical, and Here you can say horizontally. Let's go from imaginary axis, that is vertically, correct? So in that case what you will be having, your limit will be 0 comma delta y, it will tend to 0 comma 0. That means in your first equation, not this one, in this equation you have to substitute delta x as 0, delta y will be as it is. Now let us put and see what you are having, correct? So you will be having f dash of z is equal to, क्या आएगा ये, u of x naught comma, oh I should write limit, limit delta y tending to 0, it will be your u of x naught comma y naught plus delta y minus u of x naught y naught, that is a constant value that won't change. In the denominator it will be delta y. This is first expression. In the denominator it will be, I think, I delta y, correct? Because in the denominator you are having delta x plus I. This is 0, so this will be I delta y. Yeah, that's perfect. What next? Now if you take I common, then same thing, plus limit delta y tending to 0, uh, I'll write I here, plus I times limit delta y tending to 0, it will be v of x naught comma y naught plus delta y minus v of x naught comma y naught divided by I delta y. Do you agree? But in this case this I and this I will get cancelled, correct? I'll just write with different, this I is cancelled with this one. Okay, what about this one? This I is here, I don't want I in denominator, so what should I do? What should I do? Yes, Remit, can you hear me? Satish? Perfect, very nice. Multiply, divide by. So I'll multiply here and divide by I. So in the numerator it will be just I into this I, and I is I square, correct? So what are you having now? Can you tell me what is this term? Delta y, if you forget about this I, correct? That is I square is minus 1. So it will be minus something I. What is that something? Can somebody tell me? Plus here your I get cancelled. It will be Vy. This is Vy. Can somebody tell me what is this thing? Yes? Observe that. It is Uy, na? Partiality of U with respect to Y. So you are having, now if I write it like this, that is Vy minus Uyi. Is that clear? That is real part first and then later imaginary part. Is that clear? And the value is f dash of z ka value. So I'll write equation 2. Look at the proof once again. Here you are having f dash of z is equal to this. So can you say something now? As my question was, can you give me some relation between u, ux, uy, something like that? Do you see something now? Left hand side is derivative, right hand side is different. So from 1 and 2, can you say? From 1 and 2. What you are having? Let us compare real part with real part. Here real part is ux and here it is Vy. So you are having ux equal to Vy, and what is this? Vx equal to minus Uy. So can I write it as Uy equal to minus Vx? I just want to write U first, then I'll write. Is that clear? Ux equal to Vy, Uy equal to minus Vx. So this is what I am. I just wanted a relation between U and V. Correct? And just go back the proof and see if you understand everything or not. If you don't understand at any point, then you may ask to me. So abhi tak actually whatever I proved, if I reframed it properly, if I write it properly, that means first I proved, now I will write the statement. You see, theorem. जो भी हम लोगों ने proof किया, I'll write the same thing. You'll observe. Suppose that your f of z is equal to u of x comma y plus I times v of x comma. See, we started hunting for something and we found something beautiful. Correct? Now let us reframe and make a theorem now. So what was our assumption in this? We are having only one assumption, that is it derivative exist at a point z naught equal to x naught plus I y naught. Okay, then can I say the first order derivative exists? First order partial derivative of u and v must exist at that point at x naught y naught, and they must satisfy Cauchy-Riemann equation. That is, what is Cauchy-Riemann equation? Ux equal to Vy and Uy equal to minus Vx. Do you see? Ux equal to Vy, Uy equal to minus Vx. Whatever this thing is, this is called Cauchy-Riemann equation. Correct? Also, the derivative f dash of z naught can be written as f dash of z naught is equal to ux plus I vx. करेक्ट. सो अभी तक हम लोगों ने यही प्रूफ किया. डू यू एग्री? वेर यू एक्स एंड वी एक्स मैं एट एक्स नॉट वाई नॉट की बात कर रहा हूँ. डेरिवेटिव एट जेड नॉट है. या सो डू यू सी, अभी जो मैंने स्टेटमेंट लिखा, आई प्रूव्ड एवरीथिंग जो भी चाहिए था मेरे को. आई प्रूव्ड एवरीथिंग देयर. And that equation ux equal to vy and uy equal to minus vx, that is your Cauchy-Riemann equation. You remember this thing? Now, what did we prove just now? We proved that if function is differentiable, that is derivative exists, then it satisfies Cauchy-Riemann equation. You may ask, sir, what about the converse? If a function satisfies Cauchy-Riemann equation, is that differentiable everywhere? Or at that point? question must arise in your mind that, sir, what about so let us do some example first, then we'll go back to that question. Suppose you are having f of z is equal to x square minus y square plus I into 2xy, correct? Now if I want to check this function is differentiable, then what should I check first? As per the previous theorem, if it is differentiable, then next step it should be it should satisfy Cauchy-Riemann equation. Now if it fails to satisfy Cauchy-Riemann equation, then I can clearly say this is not differentiable. Do you agree? So to proving it is not differentiable, it is easy to I'll write, to prove a function is not differentiable, a function is not differentiable, you can use previous theorem. Previous theorem, what is previous theorem? That is, if it does not it does not satisfy CR equation, that is Cauchy-Riemann equation, then it is not differential. Contrapositive, do you see? I was telling differentiable implies CR equation, so what is contrapositive of that? Does not satisfy CR equation, that means it is not differentiable, correct? Now let us check. Suppose I am giving a function f of z and I am saying you that this function f of z which I have given, f of z, is differentiable everywhere. This is what I am saying to you, correct? And f dash of z is 2z. Verify CR equation. The question is verify CR equation. So in this case, the function I am giving, I am telling you this is differentiable and the value is 2z. Can you tell me what the function is in terms of z? Can you observe? Anyone? What is my function if I try to write it in terms of z? You should answer. If you have seen the derivative, what you are getting the derivative, then you should quickly answer that. What should you? Anyone? Z square, very nice, perfect. Z square. Once you are having z square, derivative will be 2z. So that is what. Correct. Now I am given that function is differential. Can you verify CR equation? What is u? What is v? F of z is equal to x square minus y square plus I times 2xy. Correct. What is u of xy? And what is v of xy? If you don't like, I'll go a little bit much comparing. Let us write 10 standard thing. Comparing with f of z is equal to u of x comma y plus I times v of x comma y. So then you are having u of xy is equal to x square minus y square, and you are having v of xy is equal to 2xy. Correct? Now what is CR equation? I hope now you remember the CR equation. We'll be using it everywhere. Tell me what is CR equation. Yes? Start with ux. Ux is equal to vy. Start with uy. Uy equal to minus vx. That's it. This is so simple to remember, I think. Now you just have to verify. That means start with find ux, uy, vx. Let's see whether it is satisfying the CR equation or not. Quickly verify and tell me. Did you verify? Yes, I cannot hear anyone. What is UX? UX means, do you understand what is UX, VY, UI, VX? This is partial differentiation. That means UX matlab you have to differentiate X, you have to keep all other term as a constant. So what will be your UX? X square, it will become 2x and Y will be 0. Yes, and what is UY? What is UI? U, UY. U with respect to Y I am saying. Perfect, minus 2y. And what is Vx? 2y. And what is Vy? 2x. Do you observe it is satisfying CR equation? These two people are same. Ux equal to Vy and Uy equal to minus Vx. Yeah, they are satisfying CR equation. Correct? And as per the rule, what is derivative? F dash of z, it is ux plus ivx. Correct? So what is your ux? Ux is your 2x plus I times vx 2i. So I can take 2 common, so it is 2z. It's verified. Do you agree? Yeah. Okay, let us see the next one. F of z is equal to mod z the whole square. Okay. So what is your u and v? Can you quickly tell me? What is your u of xy and what is your v of xy? Yes. What is u of xy and what is v of xy? Come on, answer.